This is part 5 of my 6-part video series using Altera Quartus version 12.1, SOPC Builder, and the NIOS suite. For this walkthrough, what I'm going to do is I'm going to teach you how to add an SDRAM controller to dramatically increase the amount of RAM in your SOPC designs. So up until now, we've been using 8 or 25 kilobytes of RAM. But with this SDRAM input, I'm going to show you how to use 8 megabytes. So when you're designing your chip for bigger purposes, such as using the LCD board and other components on it, you won't have memory overflow issues. So first what you do is you're going to load up your SOPC design. So you can do that by either going to Tools, SOPC Builder, or just double-clicking your design. Okay, as you can see, I have the SDRAM chip down here. If you notice on the left-hand side of this window, you can go in and add the SDRAM controller by going to Memories and Memory Controllers, External Memory Interfaces, and then the SDRAM controller. So let me open this up and show you what I did. I selected the data bus width to 16 bits and the presets to custom. And then under timing, I just left everything as default and then clicked Finish. Don't forget to go back up to your CPU and make sure your memory is on the SDRAM and not your on-chip memory too. And then select Finish. You're going to have to regenerate your SOPC chip. So you're going to click Generate. It's going to go through your code again. It's going to take about a couple minutes because it's a lot of code. And then you can close out of this window. You may have to go back in and add your 7-segment display SOPC chip. Depending on what version of Altera you're using, it may auto-populate. If not, all you do is you click this button up here, where you go to add any other module, under Project, and you'll see your display here. You have all of these different outputs over here. You're going to need to create the bus outputs. You need an output for everything, and just rename them, like I've done here. They're all going to get assigned to pins later. So next what you need to do is create a clock timer using the ALT-PLL inside your MegaWizard function. So how you open that is, you go to Tools, MegaWizard Plugin Manager. So what you're going to do is you're going to create a new custom MegaVaria function, type in ALT-PLL, PLL, and select that. So let me go through and show you how I did mine. You'll get that, and this window will pop open after you select the proper function. You're going to want to set your megahertz to 50, your value. This will be default at 100. You're going to adjust it to 50. Click Next on that page. Leave this as default. Select Next. Leave the default settings for clock switchover. Make sure to set your clock phase shift to -3, and make sure right here under requested settings you have 50 megahertz as your output frequency. Next to the clock 1 and clock 2. Next to your EDA and your summary. Make sure SDRAM, PLL, BSF, and CPM are checked, and then click Finish. Then you'll add it into the circuit, putting it between your clock input 1 and your output for SDRAM clock. And you're just going to draw a line down from here to your clock 0 on your SOPC chip. So hopefully by now you've named all of your inputs and you've set at least your clock to pin N2. So what you're going to have to do now is open up your pin planner again and make all of your pin adjustments for all of the outputs on that RAM. So all your addresses get a separate pin. These are all timers or on-chip memories for the Cyclone board that we were programming off of. So feel free to pause the video and zoom in and read some of these pins for anything you need. Close it here. And then you're going to want to recompile your chip And then once you're done with that and done compiling, you're going to go to Tools, NIOS II, select your proper folder, and then you're going to create another count example, exactly like we did in the last one, and you should run it, and it should work using the SDRAM controller we just programmed inside SOPC Builder.